Okay, so hi there, folks. We're now in our next video on college algebra, and today we're going to talk about some exercises in factorization. So I have prepared here specifically 5 items for you guys, and then we're going to start with number one. Just some recall of what are the factorization procedures. What are the procedures that we have talked about? We have talked about the common monomial factoring, difference of two squares, perfect square trinomials, quadratic trinomials, the sum of two cubes, the difference of two cubes, and factoring by grouping. So what we're going to do is we're going to apply whatever necessary factorization procedure we're going to use to factor out these examples. So let's start off with number one. We have 8x cubed minus 27y cubed. So what factorization method will we use in this one? So no doubt this is going to be, we're going to use the difference of two squares. Since this is a minus sign, or rather two cubes rather, the difference of two cubes. So this is a minus sign and we have a cube here. 8 is a perfect cube of 2. 27 is a perfect cube of 3. Y cube is also a perfect cube. So this is difference of two cubes. So again, what's the formula here? So we have a cubed minus b cubed is equal to a minus b times the quantity of a squared plus ab plus b squared. Okay, so that's our formula. We're going to follow that in this example. So a cubed here is 8x cubed. So what is a? Just a. So we need to get the cube root of 8x cubed. That's going to give us cube root of 8 is 2, cube root of x cubed is x. And here, b cubed is equal to 27y cubed. So what is b? The cube root of 27 is 3. Okay? If you don't want to believe with me, so 3 times 3, 3 squared is 9, and 3 cubed is 9 times 3, so 9, 18, 27. There you go. So we have 3y. And then we're going to apply this formula. So if we do so, this will give us a minus b. We have 2x minus 3y. A squared. A squared is 2x squared. So 2x squared is 4x squared. Since we are squaring, not only the x, but the entire 2x. That's going to give us 4x squared, right? And then let's have the a times b. So a times b is 2x times 3y is 6xy. And how about the b squared? So we have is 3y squared. So we have 9y squared. So pretty much that's our answer. Okay, and this is our answer for number one. Okay, so pretty much that's it. Let's proceed to number two. Okay, for number two, we have 25 ax minus 45 bx minus 55 ay plus 99 by. So I suppose we're going to make use of factoring by grouping. Um, it can be obvious in this part since 25 and 45 are both divisible by 5. Both of them have x's. In this part, 55 and 99 are both divisible by 11, so let's put it there, 5x. And both of them have y's there, y. So if we're going to take that out by factoring of group by getting the common monomial factoring first. So what we have is 5x times the quantity of, we have 5a here, which is left, and we have minus 9, what, b, minus 9b. And then, say I want to get the minus sign here in the 11y, so what we will put is minus 11y. So what will happen here? So the 55 divided by 11, negative 11 is just 5. The negative sign is here, right here. And then what we have is 11a. And then since this is positive, so this should be negative. So multiplying two negatives will give us positive. So this is 9b. Okay, and then we can see here that we can both have the same grouping, 5a minus 9b. So if we're going to follow that, we're going to get this group 5a minus 9b out. 5a minus 9b times the quantity of 5x minus 11y. Yeah, and that's our answer for number 2. Okay, what we used is factoring by grouping. Okay, factoring by grouping. Okay, let's proceed to number 3. Okay, for number 3, okay, number 3, what is given here is what is 24a cubed b raised to 6 plus 40a to the 4 to the fourth b to the raised to the power of 5 plus 72 a raised to 7 b raised to 7. Now following this procedure, what do we have? I think we can use the CMF, the common monomial factoring. So what do we have here? What is common? So look at the coefficients first. What is the common number that can divide all of them? What's a common number that can divide all of them? So let's be contented with 4 first. Maybe if it's greater than 4, so we can adjust. Okay. So and then what is the a? So for a, I think a with the least is a cubed. So if we're going to choose a cubed, this will be deleted. And then I think the least for the b is b raised to 5. So I think this is their common monomial factor. So if we get that common monomial factor, we're going to put that outside the parentheses. So we have 4a cubed b to the 5th times times 24 divided by 4. It's going to give us 6. And then a cubed will be erased completely here. And what is left is b, only b, because it's going to be minus 5. So b plus 40 divided by 4 is 10, obviously. And we have a, that's going to be minus 3. And b minus 5 is going to be cancelled out. And 72 divided by 4. So let's check. 4. So we have 1, 4, 32. How many in 32? See, 8. Okay, and 8 times 4 is 32 indeed. So we have 0. So yeah, that's our our coefficient, 18 plus 18 minus 3 here. So we have a raised to 4. And b minus 5 here is b squared. And yeah, this is our answer for number 3. Okay, simply we use the common monomial factoring to factor out this term here, this common factor in all of the terms. Okay, for number 4, okay, let's proceed to number 4. Number 4 is like this: 49x squared minus 81y squared. So obviously, this is the difference of two squares, difference minus sign. This is a perfect square. And this is a square root. The square root of 49 is 7. This is also a perfect square. Square root of 81 is 9. So we're going to follow the formula. A squared minus b squared equals a plus b times a minus b. It doesn't matter. It can be a minus b to be written here first. So let's answer that. We have a squared is equal to 49x squared. So what is a? We need the value of a. Square root of 49, like I said, is 7. Square root of x squared is x. Okay. B squared is equal to 81y squared. So what is b? Square root of 81 is 9. Y squared. Square root of y squared is 9. 9y. Or rather y only. So if we're going to use the formula here, so what we have is 7x and 9y. 7x and 9y. So we're going to put plus here and minus here. And yeah, this is our answer for number 4. This is our answer for number 4. Okay, and lastly, we're up to our last and final item. So what we have is number 5. um let's write it here. So we have 3x squared minus 10xy minus 8y squared. So obviously this is the quadratic trinomials. This is the hard case since our leading coefficient is not equal to 1. So if you can still remember our box method, we can use it here. Okay? Or maybe we can just, think. Okay, let's think of two binomials in this part. If we're going to multiply two numbers, it will give us 3. So since 3 is a prime number, we have no choice. It should be 1x and 3x on here. Okay, it's a prime number, so we have no choice. Okay, now we want to have a negative 8y, so it should be a y here. And we have 8 as negative. So since we're multiplying it, one should be positive, one should be negative. So it can be um, one should be positive here, it can be negative here, or if it is negative here, it should be positive here. So what numbers will give us those? Okay, so what are the factors of 8 first? So the factors of 8 are, it can be 8 times 1, it can be 4 times 2. Yeah, those are the two choices that we can have. Okay, those are the only two choices that we can have. Let's try this first. Okay, so since the middle term is negative, so we're expecting the one with the bigger absolute value is going to be negative. Okay, it's going to be negative. So let's try to put 4 here for now. 4 and then 2 here. Let's be contented with, let's use this pair first, plus and minus. So we have, let's try x plus 4y times 3 minus 2y. So let's check x, sorry. So we have 3x squared. For the last term, we have minus 8y. That's good enough. How about in the middle term? So use the O for the FOIL O here. This is going to give us um, negative 2xy. And then multiply the 2 here, 12. So we have positive 12 xy. Yeah, that's gonna give us 10, but it's not negative 10, it's positive 10. Okay, so meaning there's something wrong with our choices of numbers. So let's try to erase this. Not really the choices of number, the operations rather. Okay, the signs. Now, let's try to flip it. Let's put minus sign here. Let's put the plus sign here. Okay, and let's try. So first 3x squared. Outer rather. So we have plus 2y. Inner. So we have minus 12xy. This is 2xy. Sorry. Let me put it that again. Um, okay. And this should be 2xy. And lastly, for y, minus 4y times positive 2y is going to give us negative 8y squared. Now let's combine the middle terms. What we have is 3x squared. So 12y plus 2 is going to give us negative 10xy. And then lastly, we have minus 8y squared over here. Okay, so yeah, I think this is pretty much our answer or our original term here. So which means our answer here is correct. Okay, our choice of binomials here or two binomials are correct. Okay, so you may use the box method. I'm pretty sure it will lead you to the same answer for the box method procedure. And yeah, if you want trial and error, actually, if you're just fast, it's okay to use the trial and error. Okay, no hurt in that. Okay, so thank you very much for watching. This is our solution video for the for the exercises in the factorization of um factorization rather factorization of expressions, shall we say. Okay, so that's it. Thank you very much. Don't forget to like and subscribe, and I hope to see you soon. Okay, and then in the future videos. Okay, thank you very much. Bye.